Hello and welcome. Today we are going to talk about matrix multiplication. Matrix multiplication. Now, in my last video, we talked about this little bit, like there are two by a scalar, and you know how to do that, that's pretty easy. And today, a matrix by matrix, matrix times matrix. Now, this is little bit actually counterintuitive. So let me give you the rule first. Let's say we have 2, 3, 4, 5. This is a 2 by 2 matrix. And let's say 1, 2, 0, negative 1. Again 2 by 2 matrix. If the sizes are same, yes, we can multiply, but it's not just the case. There is more. But let me tell you how to do this. So you take the first row and first column. So first row of the left hand side matrix and first column of the right hand side matrix, and you multiply and add term by term. So 2 and 1, 2 and 1, so 2 times 1 plus 3 times 0. So 2 times 1 plus 3 times 0, whatever that number, you put in first place or the 1 place. So see, that number is going to be 2 into 1, 2 and 0, so it's just 2. So this place right here is A11 entry, right? And that is coming from first row and first column. See, that's the idea of matrix multiplication. Now let's quickly do the others. So next one, this row and this column. So first row, second column, 1, 2 entry right here, this entry, and that's going to be, so 2 into 2 plus 3 into negative 1. So you get 4 minus 3, which is 1. And for this one, this is 2, 1 entry. So second row, first column. So second row, first column. So 4 and 1, 4, 5 and 0, 0. So 4. And this entry right here, A2, 2, second row, second column. So second row, second column. 4 and 2, 8. 5 and negative 1, negative 5. So 5 minus 8 minus negative 5, 3. I think that should be clear, right? Now, let me write down the general rule. A, the matrix A, let's say M by N. P, let's say P by Q. You can multiply if and only if you can multiply only if N and P are the same. A times B exists if N is same as P. So that means, for example, let's see an example, then you will understand. So 3, 2, 1, 5, 1, 0. So let me take easy numbers. Now this one is 2 by 3 matrix, 2 rows, 3 columns. Now the matrices, so let's call this guy A. The matrices that I can multiply with A, putting A on the left, and B, that matrix, whatever that is, it must start with 3. 3 by something. 3 by, let's start with 3 by 2. So 3 rows and 2 columns. So 1, 2, 3, 1, negative 1, 0. That's it. So 3 rows and 2 columns. Now let's see. So when you multiply this row with this column, you get this entry, and this row with this column, you get 1, 2 entry, this entry. Now we are done with this row. So let me use another color. This row, so the second row, that will responsible for the second row of the resulting matrix. So second row and first column will give you this entry, and second row and second column will give you this entry. So the resulting matrix will be a 2 by 2 one. So what is the rule here? The rule is this: see, these numbers n and p must be the same. So let me put n here because it must be c, n and p are the same. So m cross n times n cross q. The resulting matrix, if I call it C, the size of it, see in this example, 2 by 3 with 3 by 2, you get 2 by 2. So the size is determined by the remaining numbers, the corner numbers, the outer numbers. So in this case, M cross Q. Now let's verify this for ourselves, let's quickly verify this. So let's take again 3 by 2. So you have 3 rows. So let me write A, B, C, D, E, F, G, H. I actually 3 by 2, so I don't need this. So 3 by 2, and this can only be multiplied with 2 by something. If I go with 2 by 1, how about this? 2 by 1, so X, Y. So two rows, 1 column. Now the result is, so this row with only 1 column, so this row and this one. So first row, first column, 1, 1 entry, A11, this guy. And we are done with this row. This row with this one, this row with this column, 2, 1 entry, so A21. And we are done with this row. This row with this column, 3, 1 entry. And the resulting matrix, I told you, it's given by these two numbers, 3 by 1. See, this matrix is 3 by 1. Now I think you can understand what's going on here. If I had another column here, let's say UV, if that is the case, see, if that is the case, first row with first column, yes, A11, and then first row with second column, A12, and like that, A22 and A23, I will have this is 2 by 2, so 3 by 2, right? So if you have a matrix with 100 by 5, and this matrix, the right hand side must start with 5 by, let's say, 48, the resulting matrix is 100 by 48. I think now this is clear, right? Now let's see some examples. Okay, how about this? -1, 3, 4, 2, sorry, 4, -2 by 0, and let's call this guy A, and B, -3, 2, -4, and 1. So the first question, find, find AB and BA if they exist, or if they don't, you have to tell why they don't exist. Let's start with AB. So AB, what you need to do, okay, A is 3 by 2, B is 2 by 2. So these numbers, yes, they are the same, so yes, it exists. So you can move forward. 5, 0, and 2 by 2, -3, 2, -4, 1. So the resulting matrix is 3 by 2. So open a matrix, so you can put a 3 rows and 2 columns, so 3 by 2. So 3 rows, 2 columns, so 6 entries. 3 rows, 2 columns. These are the places. Now let's see. this guy with this guy, that will 1 1 entry. So negative 1 into negative 3, that's positive 3. 4 and negative 4, 4 and negative 4 and 3, 12. And you get negative 9. And this guy with this guy, if you want, you can write it down like this: negative 1 into 2 plus 3 into 1, even here or in a separate place, and then you can do that. So that should be 1, and this is negative 9, this is 1. Now we are done with this guy, so this guy and this, so 2 1 entry, negative 12 and 8, so you get negative 4. And then this with this, 4 and 2 8, negative 2 and 1 negative 2, so you get 6. This with this, so 5 and negative 3 negative 15, 0, so just negative 15. And 5 and 2 10, 0, so just 10. I think that should be clear, right? Now how about BA? B is 2 by 2, A is 3 by 2. This does not match, so BA does not exist. I think now that should be clear, right? So what does this mean? AB does not equal BA in general, because see, sometimes they don't even exist. Even if it exists, now let's say, take an example, a simple example. So let's make it square matrix. So 1 2 3 4, B 0 negative 1 1 2. So I'm just randomly taking some numbers. They both are 2 by 2, so the numbers agree. You can multiply. 1 2 3 4, AB 0 negative 1 1 2, and this row with this, so 1 and 0 0, 2 and 2 is 2, so you get 2. And this row with this, so negative 1 4, so 3. This row with this 0, so 4. This row with final this, so negative 3 8, so 5. That's AB. How about BA? 1 2 1 2 3 4. So the other way around, these two, so 0 and 1 0, negative 3 and 1 negative 3, so I get negative 3. See now, and I can multiply this and this, 0 0, so negative 4. Now this and this, 1 and 6, so 7. This and this, so 2 8 10. See, in this case they both exist, but still they are not the same. Okay, so that's an important point. Now how about this? Let's say 5 4 3 2, and let's say xy. So first one is 2 by 2, second one is 2 by 1. So yes, we can multiply. So if we multiply, what do we get? 2 by 1, right? See these numbers, 2 by 1. So this with this, 5x plus 4y, that's the best I can do, and 3x plus 2y. Now let me show you something. Now in algebra class, recall in algebra, college algebra, or intermediate algebra, whatever, 5x plus 4y equals, let's say, 9, and 3x plus 2y equal, let's say, 5. So these are systems of equations, systems of linear equations. You have two equations. See, look at this. This is this, right? Now this can be reduced to a matrix form. This is why we learn matrix, guys. And xy equal, and we can put this guy in this. So this is the matrix form of this system. This system. And in future, we'll be dealing a lot with this kind of system, and we'll learn how to solve them without solving equation, but just by using theory of matrices. But we have to first build up some theories. So, summary for today's video: A B exists, so M cross N cross P. So see, these numbers must agree in order for that to exist, and the result in matrix Z is given by these two numbers M cross P. That's the first thing you learned. Few tips: AB does not equal BA in general. So it may be the case AB, if AB exists, okay, let me put it in this way. If AB exists, first, BA may not exist because of the sizes. Second, even if it exists, in general they are not the same. Now, to finish the video, I'll give you a few questions. Can you find two non-square matrices A and B so that AB and BA exist? They both exist. So AB and BA does not have to be the same. Need not AB equals BA. It does not have to be the same. Second question, can you do the same thing now? AB and BA are the same. So for these questions, some answers maybe you cannot do that, right? So think carefully. And next one, find two square matrices of the same size such that AB equals BA, but none of A or B is identity. Because if you make one of them identity, that's pretty easy, it will work. Remember last video, identity I2, for example, 1001, I3 10001 is I3. We did this in last video. So these are conceptual questions, but it will help you to understand this fact a little better. Okay, so I think that's enough for today's video. And in our next video, we will look at the answers for these questions. And then if we have time, we will go into the next section. Thank you.